I'm Kate Simpson, and I'm going to present some ideas, research, and insight on some of my data analysis in relation to the retrofit of UK homes. I'm particularly keen to present to the Eco Home Lab as I have an idea which I'll share with you, and I welcome general feedback and input to my research. I've recorded this now, hopefully we won't need this, but in case my internet connection goes a little bit weak later, I live on a boat, so that could happen, although it looks clear this evening. So I'll get started. So first of all, really happy to present to the Eco Home Lab at the Carbon Co-op, partly because I've been interested in the work of the Carbon Co-op, powered retrofit, and I've been aware that you exist, but I haven't directly engaged with you before. Here's a few pictures and a blog of the DIY retrofit training that I attended at the Carbon Co-op back in 2017. And one thing I thought might be of interest in terms of sharing this is like the DIY approach and getting people involved, empowering people. And I'm interested in that, and that's another reason why I'm quite keen to speak directly with the Eco Home Lab members. I know you take slightly different DIY approach, but I'm sure some of you cross the physical building construction and the data and technology as well. So just a little point there. The talk outline, I'll start with my motivation for the research that I carry out, and then I'll provide an overview, like a review of dwelling retrofit research that I carried out, some insights from that, consideration of home energy environment data and some research in relation to retrofit evaluation, some work that I'm doing now on uncertainty quantification, which has led to questions around, do we need more data? And I have an idea for a citizen science project, which I would like to discuss with the Eco Home Lab members. So that's the outline. My personal motivation is around climate change and the need to achieve net zero carbon by 2050 legally, or some say 2030, 2040. I think if we aimed for 2030 or 2040, that would give us a little bit of leeway. I think we need a mass experimental approach, which I don't think the majority of householders in the UK are yet prepared for. And I'm quite concerned about this. We know that it's technically possible to reduce total household CO2 emissions by over 20% by 2050, and that's old research looking at demand and supply measures from 2005. We need to achieve almost zero carbon standards, 25 million homes at least. And yeah, at the moment, as I'm sure you're all aware, we're nowhere near working towards this target. One positive from this year and last year has been the declaration of climate emergencies, which I think has been a call to action for many in the research field and elsewhere. I quite like this open access working paper, How Should Energy Researchers Respond to a Climate Emergency? Within a week of an event I attended, it was shared, and one of the statements in it is it might require researchers to work quicker, more collaboratively, and I think that is true, and that's one reason I'm particularly keen to engage teams outside of academia who are doing really exciting work like the Eco Home Lab. Here's a summary of some of the published research on dwelling retrofit. The first paper that I found was in 1968, but up until 1985 there really wasn't much. Around 2010, the rate started to increase, and that could be due to the Energy Performance of Buildings Directive, a European directive that came about in 2010. And maybe some of the research before that was in relation to building regulation changes and the Kyoto Protocol, etc. This is some research which has just been accepted for publication. It's a review of themes, data-centric research and future directions. So look out for that in the next few weeks. And in terms of themes of that research, it's heavily focused on energy efficiency. I didn't include energy efficiency in the search. I looked for refurbishment, retrofit, modernisation, repair, maintenance, every term that I could think of relating to retrofit, but I wanted to see what came up. But heavily focused on energy efficiency. And despite the number of academic publications, we're still not seeing physical retrofit at anywhere near the scale that we need to achieve. So I think we need to find ways to do things a little bit differently and also potentially look beyond energy efficiency in terms of research as well. So I've been recently thinking about data. It's always been an aspect of my research, but I've been thinking more recently in terms of data-driven decision making. And when I think about the home environment, I'm trying to take a step back and think at the moment we're looking at in-use energy, operational carbon, but there's so much more data that we could look at and we could consider. And keep this question in mind because this is something that I will come back to at the end. And I'm sure that the Eco Home Lab members have ideas around this as well. So just a brief overview of some of my background. I did a PhD on energy demand in the London Loughborough EPSRC funded CDT, which is a Centre for Doctoral Training. And I looked at retrofit and followed 14 case study householders through the retrofit process. In the end, 10 of those completed within the time frame. And I wanted to find out what their perspective of retrofit was, as well as the measured impact from the physical data that I collected. And I was keen to look at the process of retrofit, the comfort impact for the householders, and the energy demand as well, and find out if that met their perceptions and expectations and if they were satisfied as a result. Into the work that I'm doing now. So just to give a bit more insight on what I did, it was following a similar methodology to the Retrofit for the Future data collection, which I'm sure many of you are aware of, and the Carbon Co-op were involved in that. I know that Marion Hislip did some planning, managing, monitoring of some of those properties. So it followed a similar data collection protocol. One thing I wanted to do was experiment with whether we could increase the accuracy and reduce uncertainty of the modelled data by including more measured data and overriding some of the assumptions in a standard energy, standard assessment procedure, BREEAM-based energy model. So I gathered typical building survey data, monitored temperature in every room and outside, relative humidity, measured the gas. Well, it was readings of the gas meter relying on the householder at that stage. I measured the fabric air leakage or air tightness and then used that to input the model. And I did this before and after, and for some of the properties I measured throughout the entire 1.5 years in terms of temperature data. I also interviewed all the householders and found out like what they expected, gathered like perception on comfort, and that was really a key part of the work that I did. And that's one reason I'm particularly interested in the people-powered retrofit. I think without having householders on board, we're never going to achieve the targets. So I had a sample of 10 houses, mainly in the Midlands, typical, mainly semi-detached houses, quite standard. Some cavity wall, a few of the detached were solid wall. Typically, they were between mixed renovators and efficiency only renovators. So a few of them were particularly motivated to save energy. So they're the ones that are highlighted in green. Some of them just needed to repair something, like a boiler or their windows, they wanted to replace the windows. And they were a mix of young households, households with children, potential movers, and empty nesters and pre-retirement. And it seemed to be those without children at the moment who were more motivated to save energy. It's very small sample, so I can't say too much, but they were a particular sample. Some of them were quite pro-environmental. So these are the methods which I employed. So actually, first of all, actually the measures that they installed in terms of BWI, which is on there. B is for boilers, W is windows, I is insulation. And H4 went all the way to a passive house equivalent, the AECB Silver Standard. Some of the others installed external wall insulation, and a few of them it was just windows and boilers. They were all interviewed, they all had surveys, they didn't all complete an air tightness test. Temperature was monitored in all of them. For most of them, it was over a year at least. And then meter readings were gathered for most afterwards. For some, it was pre and post measured data, depending on the time available. In terms of comfort, so most of them didn't necessarily expect that they would have an improved comfort, thermal comfort after the retrofit, but many of them unexpectedly did increase their comfort in the home, as well as noticing benefits such as reduced condensation, and also acoustics. For many of them, they had quieter boilers or they had reduced noise coming in from outside. And then other benefits that you'd expect, like reduced heat loss. Many of them didn't really think about drafts and airflow in the home, but that improved for quite a few. I should say that because I was measuring air leakage, I think that gave them the incentive to do more draft proofing as well. And then I measured the indoor air temperature and pre and post, and I normalized it at 5 degrees of outdoor temperature. And for nearly all of them, there was an improvement to that. And this is taken during the night because that's when typically the heating was off for most people. And also that shows that there was decreased heat loss through the evening. For H1 who installed external wall insulation, this chart shows before and after the retrofit in terms of the linear line that's going through the middle. It shows that afterwards, which is the little boxes, it was a more constant temperature and less dependent on the outdoor temperature, and that was after installing external wall insulation. Air tightness test results were gathered and used these to look at air changes per hour. And for nearly all of them, this decreased. For H4, it's significant because, as I said, they went to almost passive house standard. Some of them, H8, it was too leaky before the test, but I managed to measure after the retro. For most of them, their expectations were exceeded in terms of energy demand reduction. I looked at modelled space heating and added the temperature data that I'd measured, and for most of the properties this brought the modelled estimate closer to measured data. So here you can see the difference between measured and modelled. For some of them it was very close, for some of them it was still a huge gap. And at that point in the study, I didn't have enough time to do the sensitivity analysis to understand exactly what was going on for H8 and H9. But having the measured temperature did bring it closer to the assumption. Another factor is that it was immensely disruptive, and it's always easier not to carry out a retrofit. This got me thinking about the installer's perspective. So one thing was installers often provide the information to householders, and if they're not very informed and they can't make the process smooth for the householder, then that's going to limit how many retrofits we can achieve. So just a little aside, there was some real strong findings around like not having a critical mass of green building expertise, and people find it very stressful to go through. I did a little bit of work between that PhD and what I'm doing now, looking at the installer perspective and training and skills to deliver. And I still think that's a very important area. And I hope in the future that we can use data in a circular way to inform back to the stakeholders involved in retrofit on the impact of the work that they've done. And I think that might help to close the loop to upskill, provide better training, etc. And what I'm looking at now, data-driven design under uncertainty. So there's lots of different types of uncertainty in retrofit and also building energy modelling. particularly the occupant behaviour, the weather conditions, thermal properties, risks, moisture, fire, financial. There's a lot of uncertainty in retrofit. What I'm focusing on right now is looking at how we can increase the accuracy of bottom-up engineering models focused on individual building archetypes. And I'm using the BREEAM methodology, the same methodology used to generate energy performance certificates, because that's a model which we're already using to make policy decisions. And I think if we can improve that and make recommendations to improve that, that could be really valuable. There is work going on at the moment looking at operational energy as well, but I still think there's scope to improve the modelled estimates of energy performance before and after retrofit, because I think that's particularly valuable for the retrofit design stage. And sensitivity analysis of BREEAM by other researchers has shown that the mean internal temperature and the length of heating period are the factors that are most sensitive, or that the building energy model is most sensitive to. So I'm quite interested in that temperature. And we know that the BREEAM model assumes like 2 set heating periods in the day that are often above what people actually heat to. And there's been some work in Loughborough looking at how to categorise different householder archetypes. And I'm thinking about taking this forward. And I'm wondering if we have more data, could we further develop archetypes around age, employment status, maybe preferences, persona types. And so the uncertainty in temperature and heating patterns, it's aleatory uncertainty from processes that are inherently random. And you can address it using a probabilistic framework or more measured data, but it's almost impossible to eliminate. So I've been looking at the probabilistic framework and the Bayesian calibration process, and it's just something that I'm doing at the moment. But again, in terms of validation, the post-calibration model should be compared with measured data. So I'm thinking we probably need more measured data on what's actually happening in UK houses. And we know that post-occupancy evaluation data is much more than just the temperature and the energy. There's many more impacts. There's thermal comfort, indoor air quality. There's also the aesthetics and what people like about the building. So I'm also interested to know if, while gathering more temperature data, there's scope to gather more data which could then inform future retrofit decision makers and the householders about the impact of previous retrofits. Complete. And at the moment, there's some open data on home energy, and there's a few good data sets at Loughborough. There's like the low energy building database, and there's some government-led data sets. But it's a little bit patchy in terms of what we need to know about the impact of retrofit. And I think we have scope to do much more. So one thing I'm looking to do at the moment, and I'm starting to plan now for my next project, building on what I'm exploring now in terms of uncertainty. And I'm interested to explore open and citizen-led data that can inform retrofit. And this is something that I'm keen to speak to the Eco Lab community about, because I know that this community are quite data aware, engaged, already engaged with the Carbon Co-op. So I'm keen to find out if you think it's a good idea. I have applied for a citizen science grant, and if that is awarded, it would be great to then engage more with you. At the moment, I'm developing a protocol for the post-occupancy evaluation that I can share openly on GitHub. And I've only just started working on that, but these are the ideas I'm keen to hear from you about. And one inspiration for this work is the Turing Way Guide to Reproducible Research. And for those interested in open data, I recommend taking a look. It's an open book project, open from the start. And it's taught me quite a lot about more collaborative ways of working. And I'd be interested to find out if, that's of interest to team members here to explore maybe developing something like that for the retrofit community. So discussion points. Number one, do we need more open data? Retrofit evaluation. Could citizen science be a good way forward for this? Are Eco Home Lab members interested in this research? Does it cross with what you're doing and hoping to do? And do you think an approach like this could potentially empower citizens, progress knowledge, minimize risks in retrofit, and help to accelerate progress and allow ideas sharing?